So for the final parametric equations video, we're going to be looking at intersection points and a bit of differentiation. So we have this curve C, which has parametric equations x is t cubed minus 8t and y is t squared. And they said where t is a parameter and given that point A, t is -1. In question A, they're asking us to find the coordinates of A. So given that t is -1, what we do to find the coordinate is just simply plug it into the parametric x and y equations. So x will be -1 cubed minus 8 times -1. This is -1 plus 8, so 7, and y is just 1, so therefore the coordinate of A will be 7, 1. Just plug it in. Now in part B, the line L is a tangent to C at A. Show that the equation is this here. Right, for a tangent, we need to work out the gradient first, right? And we'll look at this further on in the parametric differentiation part in the next chapter. But to find the gradient, dy by dx, we need to find y in terms of x, right? So we could find the Cartesian equation first and then differentiate it. However, this is sometimes more difficult to find, and it might be a more difficult differentiation to do. So what we can do instead is I can differentiate each term itself separately and then divide it. So I'll do dy by dt and then dx by dt and then divide it. And that's the same thing as dy by dx. This is known as parametric differentiation and is explained in more detail in the differentiation part of the series later on. Right, so I have y is t squared, so I can differentiate this dy by dt is equal to 2t. We have x is t cubed minus 8t, and therefore dx by dt is equal to 3t squared minus 8. So therefore my gradient dy by dx is going to be dy by dt, so 2t over dx by dt, which is 3t squared minus 8. So this tells us the general the gradient equation, and I can plug in t is -1 because we're still looking at the a coordinate. So we're going to have 2, -1, 3, -1 squared minus 8. This is going to be -2, this is 3 minus 5, -5. So the gradient the tangent at A is 2 over 5. So y is going to be 2 over 5x plus c. We know the coordinate of A is 7, 1, which I'm going to plug in as well. So we're going to have 1 is equal to 7, so 14 over 5 plus c. Therefore, c is going to be -9 over 5, so y is 2 over 5x minus 9 over 5. And just writing in what the form they want us to write it in, it's going to be 2x minus 5y minus 9. Okay, so don't get too flustered about this differentiation part here. We'll learn it in more detail in the next videos for differentiation. Right, now in part C it says the line L also intersects the curve at point B. So this line is L, okay? And this is the tangent line at A, but they say it's going to intersect the curve, being this curve here, at another point B, and they're asking us to find the coordinate of B. So what we can do is actually, we could once again create the Cartesian equation and then equate them together, right? Because we're literally just trying to find the intersection points. But rather than doing that, because once again it could be difficult, what I'm going to do instead is I'm going to plug in my parametric equations into this line equation. Because at the intersection point, not only do the Cartesian and the line intersect, but the parametric equations and the lines would also intersect as well. So I can say that 0 is equal to 2 times x, which is t cubed minus 8t, minus 5, y is going to be our t squared minus 9. So you can see now we have an equation in terms of t. And so what I need to do is just find the t values. So I can say that 0 is equal to 2t cubed minus 16t minus 5t squared minus 9. And it's a cubic graph. So we're trying to find the factors of the cubic graph. So what we can do is actually do algebraic division. Because we know that at one of the points on that line is when at point A, right? And that was when t was equal to -1. Okay, so we know that is a factor. We can call it a factor, right? So I can say that, if I divide it by t plus 1, then we should have a remainder of 0. So 2t cubed minus 5t squared minus 16t minus 9. This is just algebraic division, which was in the first chapter. So 2t squared minus plus 2t squared of minus 7t squared minus 16t. 7t squared minus 7t. And then minus 9t minus 9 minus 9 minus 9t minus 9 is 0. So we know it's a factor. So we can rewrite that as t plus 1, 2t squared minus 7t minus 9 is equal to 0. And therefore, I can say that it's t plus 1, and I can factorize this as well. So we're going to have 2t, t, we can have minus 9 plus 1. So t is going to be equal to 9 over 2 or negative 1. We've already used this negative 1, right? So the coordinate of b is when t is 9 over 2. And once again, when I want to find the coordinate, I can just plug it into my equations, parametric equations, and I will get the coordinates of b. So that's how we just manipulate or find points of intersections. Rather than having to find the Cartesian equations, we can equate in parametric equations and plug it into a Cartesian equation to find it in terms of t first, and then plug it in to find our coordinates. So it's a much easier and sometimes it's a much easier and quicker way of doing it. And it stops us having to deal with more difficult Cartesian equations. Other key points that we should be aware of, sometimes they might ask you, well, where does it cross each axis? So for example, it crosses the y-axis here, right? So the way we'd find that is when we can say the same thing, x is 0. So find the t values for when x is 0. So this is equal to t cubed minus 8t, t squared minus 8. So it's when t is equal to the root of 8, right? And I can plug this into my y squared value here and find where it crosses the y-axis. So in this case, it's going to be at the coordinate 0, 8. So that's another thing that they could ask you. But in general, it's just plugging in the parametric into the Cartesian to find it in terms of t first.